Hello class, today we're on lesson number 2 in chapter 6 and we're going to be covering formulas. Now that we've learned how to use two variables within an equation, we can now look at formulas. Generally a formula will have at least one variable, but could have many. And in this particular case we're going to see two variables as we've been using. And we have an illustration here of the heaviest human being of all time. Well, at least it was at that time, because this has changed. This book was published in 1979, and would you believe there have been individuals much heavier than this individual? But let's read on. Perhaps the heaviest human being of all time was Robert Earl Hughes, whose greatest recorded weight was 1,069 pounds. 6 feet tall, he weighed 700 pounds when the photograph shown here was taken. Now, the normal weight of a man can be determined by the equation W, that would be the weight, is equal to 5.5 h, that would be height, minus 220. So let's go ahead and write our formula up here. We have W, that's the weight, is equal to 5.5 times h, or 5.5 h, minus 220. Now, in which W represents his weight in pounds and h represents his height in inches. Okay, so we completed really the formula there in determining weight is in pounds. Maybe we can make a little note over here. We talked about units and how important units are, and height is going to be in inches. Okay, so just put IN. Alright, so we have pounds and inches. Now, let's take a look here. According to this equation, a man who's 6 feet tall, now 6 feet tall would be 72 inches, 6 times 12 would be 72, should weigh approximately, well, let's see, let's plug in. We have a height which is equal to 6 feet. Now 6 feet doesn't work for us, we need them in inches, so we're going to multiply that times 12, and we're going to have the height is equal to 72 inches. Okay, so let's plug that into our equation, and what we're going to get is W. Now they're not putting the W, but I'm going to keep it in there. 5.5 times 72 minus 220. Now if we do this calculation, we should be able to determine what the normal weight of an individual is who is 6 feet tall. So when we do our math, 5.5 times 72, and that's going to be 396, and we're still going to subtract 220. And when we subtract 220, we will get the weight is equal to 176. So here we have two variables, and here's a practical application of an equation with two variables. We can determine the weight of an individual, or at least not the weight, but the normal weight for that individual. What would be their normal weight if they were a certain height in inches? And again, this is weight in pounds and height in inches. So, given someone's height in inches, it's easy to find his normal weight. By using the equation, as we have done here, replace h with the height and figure out W. Now, an equation containing two or more variables that is used to solve practical problems is called a formula. Now, let's read that again. An equation containing two or more variables that is used to solve practical problems is called a formula. Most formulas are written so that one variable appears by itself on the left of the equal sign, and an expression containing the other variable or variables appears on the right. The variable on the left is called the subject of the formula, and the formula tells us how to find its value when values for other variables are known. The subject of the formula, W equals 5.5 h minus 220, is W. The formula tells us how to find W when h is known. Okay, so that's what we call, we're solving it for W. Okay. Now, what if we want to solve this formula for a different variable? In other words, we have a w, but what if I have the w and I'm really looking for the h? Okay, we can do that because it works either way. It is frequently useful to change the subject of a formula to one of the other variables. In other words, to find the normal height of a man whose weight is known, it would be convenient to have the formula that tells us how to find h when given w. We can create such a formula by solving the formula, and let's do it. We're going to solve it for h in terms of w. So let me just clear this up over here, and we're going to do that on our screen here. It's going to get rid of this. We have our original formula there, which is w is equal to 5.5h minus 220, and we're now going to solve this for h. Okay, so let's isolate the h. Now, in order to do so, we need to apply what we've learned in the previous chapter or previous chapters. Let's say we're building up a toolkit. You might say, well, how do I solve this for h? Well, you've already been told. You know you can do certain things. You can add and subtract and divide within equations as long as you do it to both sides of the equation. So we're looking to isolate the h, okay? An easy way to get h on the left is to switch two sides of the equation. So the first thing they want us to do is just to simply switch it around. As we read here, that we try to put the subject to the left. You know, what is w? W is equal to 5.5h minus 220. So it reads the way we're thinking. We're trying to find w. So we want to put the h on the left side, so let's do that. Now, how do we do that? Well, we can just simply switch the formula around. We can just say 5.5h minus 220, okay, is equal to w. Now, that sounds a lot easier to to read where we're looking for h, because h will be on the left side, but we're obviously not done here. We're going to have to do a few things here. We're going to have to add 220, okay, as we've done. So we've added 220, and you know, I like to put my little equal sign there because we're doing it to both sides. We're maintaining the equality by doing the same function to both sides. So what we'll end up here is with 5.5h, right, and this will cancel out. Negative 220, positive 220. Bring our equal sign down, and now we have w plus 220. Okay, so we're almost home. We'll have to do one more thing here, and yeah, you probably guessed it. You probably shouted at the monitor. It's divide by 5.5, right? So we're going to divide each side by 5.5, and then ultimately what we'll get here is h is equal to w plus 220 divided by 5.5. Now, if we have the w variable, if we know a person's weight, we can now determine what their normal height should be, or it kind of sounds strange. If your weight is this should be your normal height. It's really the other way around, but basically we look at a person's height and we say, this is what your weight ought to be. Okay, you go to the doctor's office and the doctor says, you know, you're a little bit overweight and you probably could lose a few pounds. How they know this is they have a chart, and the chart tells you more or less what the weight ought to be for your height, and obviously they measure your height and weight and they determine whether or not you're within those parameters. This is just a good example. This isn't, I'm pretty sure that some of this has changed over time, and there's really a range. I'm going to remove this part up here. Okay. And so anyway, that's basically what the doctor is using. He's using a chart that's sort of using a formula, though the formula is not on there, but someone has already calculated it and they've just made it into a simple chart. The doctor doesn't have to sit there and plug in numbers into formulas to determine that. Someone's already done it for him. Now we have this, and it says here, this is the formula we're looking for. It tells us how to find h when given w. To find the normal height for a person who weighs 165 pounds, for example, and again, that sounds funny because if that's your weight, you can't change your height, okay? That's your normal height. It just reads a little funny there. And you can lose weight. You can change the weight so that you could be at your normal weight for your height. But I really have a hard time thinking you're ever going to change your height. But let's just go ahead and read on. It says to find the normal height for a man who weighs 165 pounds, for example, we can write h is equal to, and we have it down here, w plus, well, the person's 165, so let's just go ahead and write that up here. H, let's rewrite that so it's a little neater. So we have h is equal to 165 plus 220, and all of that divided by 5.5. So all we've done up to this point is that we've substituted the value 165 for the variable w. Now when we do our math, we're going to have 385 divided by 5.5. And when we divide 385 by 5.5, we'll see his height is 70. Is that 70 feet? Of course not. 70 inches. Okay? And 70 inches is about, in feet, if we were thinking in terms of feet, that would be 5 feet 10 inches. Okay? Because we knew that a person 6 foot was already 72, so I just did this math. I took 2 inches off from 5 feet 12 inches, which would be 5 feet 12 would actually be 6 feet. I just subtracted 2 inches, so it would be 5 foot 10 inches. Okay, and so we can see here that we can use formulas, and we can switch the variables around so we can solve for the variable that we don't have, and that's an important part of science. It's used constantly throughout sciences to determine what the missing value is, and that's how science really evolves in itself, is that we're able to find what those variables are. If we can create a formula that determines a truth, obviously it's something that's true, or false would not be equal, but something true would be represented in the form of an equation. So math is very helpful in science to help us not only when we have that truth, but if we only have a part of that truth, we're able to determine what the other half is and find the missing variables. And a lot of times these things are done part of a bigger problem, because we're trying to find a variable that's going to actually be used in another formula. And there may be a series of formulas that are interconnected as we're trying to find a particular answer to a problem, or we're trying to determine a certain truth. Again, I use the word truth, equals meaning something is true, and so we're trying to find something in science, particularly, let's say, that is true. So formulas are very helpful for that. There are theories that are also used in formulas, but there's some presuppositions that are built into them, and you have to be very careful with that, because if there's a presupposition, though there's certain scientific fact to it, doesn't necessarily mean that in the end we're leading up to something that's true. Now let's take a look at, we have two examples here, and let me just clear my board up, and we have a couple examples, and these are practical examples to show you how we can use two variables, how formulas, known formulas, we know, for instance, area of a rectangle, or even of a, let's say, a square. We know perimeter, and the first problem here, we actually have something that's a little bit different, okay? And it's volume, okay? So we're going to expand. We've done area, we've done the perimeter, and now we're going to do volume. It says the formula for the volume of a box having a length of L, the width of W, and the height of H is volume. Let's write that over here in our little corner here. V is equal to L times W times H, LWH. Now they write it much more, much nicer, much more elegantly. They're using like a script, and a lot of times you'll see that so that we can tell the difference in formulas. They'll use italicized, they'll use almost a form of script, so that we can tell that these are variables. And again, these variables almost become symbols in themselves in science, because when you see an L, you know what it represents, and you see a W. So Rarely do these variables get interchanged, but they do. Now let's go. Switching the sides of this formula, well, let's go with, well, we're supposed to solve, it says here, we're supposed to solve this formula for h, okay? So we have v is equal to L times W times H. So we're going to switch it around and we're going to say L times W times H is equal to V. Now, we can just flip these because 2 is equal to 2, the same as, let's say 2 is equal to 1 plus 1, and 1 plus 1 is equal to 2. So we've already discussed that in the past. So we just simply switch them on each side of the equal sign. Now we're going to solve this for H, and because H is multiplied by the product of LW, okay, we have LW times H, or, it's obviously L times W times H, but since we know that we're multiplying that H times these two factors, we can divide both sides of the equation by those two factors. So we'll divide by LW, and we'll divide by LW, both sides, right? And we'll end up with H is equal to V divided by LW. So if you have a known formula, and again, a formula is something that is true. You may not even have any of the factors. You're shown here a formula, for instance. You have a length times a width times a height. And we may not know any of them, but we know if we had all three, we could find the volume. But in some cases, you may know, for instance, the volume, and maybe the length and the width, but you need to determine what the height is. So that's why we flip these formulas around. And having knowledge of how to change our equations around and what we're allowed to do with equations just gives us such an enormous amount of power to determine the missing variable. So if I wanted to solve this for L, I would have done something different, but similar. I have L times W times H is equal to V, and I would divide by WH on each side, right? Simply because I want to isolate the L, and that W doesn't look so good. And what do I have? Well, L is equal to V divided by WH. And again, we can do this on and on. You already have the power to be able to change these equations as long as you follow the rules. And those rules particularly are what you do to one side of the equation, you do to the other. What are you allowed to do? Well, you're allowed to multiply, divide, add, subtract. And you can even change the form of it. But ultimately, as long as you keep the equation equal, it remains an equation, and you can use it again as a very powerful tool to determine what your missing factor is. Now, let's see example number 2. Solve the formula y is equal to 2x plus 1. Now we're back to x and y's, huh? 2x plus 1, and we're told to solve this for x. Again, we're simply going to apply these things that we've learned. We're going to switch this around to say 2x plus 1 is equal to y. That way we have the x to the left. Now we're going to just follow the things that we know. What do we know? Well, we subtract 1 from each side of this equation, and that will give us the x isolated with its coefficient, 2x, and we'll have y minus 1. Now we're going to divide each side by 2. And when we divide each side by 2, we'll have x all by itself. X is equal to y minus 1 divided by 2. Okay, so this is it's bringing us back to the x and y. The practical application of using length, width, and height and volume is probably somewhere where this is going to point more to. But your work in particular is going to always involve x's and y's in algebra, because we're just simply trying to teach you how to handle these variables later on. As you apply algebra in your other areas of study, you will start substituting with these other letters. So we used the practical example of volume, but we came right back to the x and y, which is primarily what we're going to do in our homework, though you will have some really nice examples here also of using other variables in known formulas.